Hello and welcome to lesson 4 of UK's Changing Landscapes. This session is going to be the first session that you're going to do on coastal landscapes and how they are changing. So this topic as a whole is divided into different sections, and the very first section is the first 3 lessons that you've seen so far. So the sections on geology, upland and lowland landscapes, and how they're affected by physical factors, so tectonics, glaciation, rivers, and how they're affected by human factors, so settlement, agriculture and forestry. So that's section 1, and it's only worth 6 marks of the paper. Sections 2, 3 and 4 are 3 optional topics where we have to do 2 of the 3. So one of them is coasts, which is what we're going to start today. The other one is rivers, which is the other one that we will focus on. And the third option is glaciated landscapes. But we do not do that one because you only have to do 2 of the 3. So we do coasts and rivers. And there's a number of reasons for that, but largely it's because there's lots of crossover between the two when it comes to the processes. So we tried and save you a bit of time really by doing those 2 topics. So this session is going to be looking at coastal landscapes and processes specifically. And the very first sort of 3 or 4-ish lessons, I think 3 lessons of coasts, it's really setting the scene to help you understand the coastal landscapes that you imagine and see. So what I mean by that is when you go to the coast has many what we call landforms, things that you see. So from a geographer's perspective, the things you see on the land that naturally occur are called landforms. Around the Norfolk coast, we don't have much in the way of kind of dramatic landforms. We have beaches. Beaches are a landform. We have cliffs, and most of our cliffs are actually quite soft and a bit, slumpy, but that's because of the type of geology that exists there. But there are parts of our coastline, if you go to the west of Norfolk in Hunstanton, that we do have hard geology cliffs and a wave-cut platform, which, again, if you're not sure what that is, don't worry, we'll explain it later. If you go to other parts of the United Kingdom, they also have things like sea stacks and arches and caves, which, again, you don't find in Norfolk, but they do exist. You also can get features such as spits and bars, which again you won't necessarily know what they are at this stage, but you will. But every landform that you see at the coast, you are going to be basically investigating and describing how that is formed and how it's created. Because remember, this whole topic is about the UK's landscapes and the UK's landscapes changing. So to be able to describe and explain how UK's landscapes change, you need to know what they were before and then how they were created to today. So UK's landscapes is going to include coastal landscapes and river landscapes. Now the great news is that you've already got the very first part you need to help you explain those things that are generated, and I'll talk a little bit more about that in later sessions. But for today, we need to start going through the processes that change the coastal landscapes around the UK. So the first session, this session, is all about these main processes of erosion, weathering and mass movement. Okay, these have been grouped together because they are essentially how chunks of the land can be changed, broken down and removed in large scales. So you're going to be looking at the 4 types of coastal erosion, the 3 types of weathering and the 3 types of mass movement in this session. There's lots and lots of notes to be taken. There's also resources on 365 as ever, and what I would say for you to do is, if you wanted to start building revision resources and revision materials, these would be really good as flashcards. Okay, so once you've written the title down, unpause the screen and I will carry on with the session. Okay, so what you've got here is a series of images which don't look at all linked, and they're not really, other than to give you a bit of a nonsense word. Okay, this word, Hyderbatsol. Hyderbatsol is not a word. It's not a word I want to see written in a geography paper, but it is a bit of a kind of method that's been used to try and help teach you 4 words in one. It's often easier to kind of remember 1 word than it is to remember 4, as long as that 1 word helps prompt you to remembering the other sessions, so the other words I should say. So Hyderbatsol is really derived by Hyd for hydraulic action, ab for abrasion, at for attrition, and sol for solution. Hyd, ab, bat, sol. Okay, so these four terms are the four types of coastal erosion. And if you get yourself onto 365, I have got an explanation for you already written down for all of these four terms and what they include. There is also videos saved onto 365 which again describe hydraulic action, abrasion, attrition, and solution. Now, what I would like you to do, okay, is create a diagram which helps you just visualize this process. All right, so here is the this again. You don't have to write all this down. This is already on 365. If you can find it, it's nicely there. This hydraulic action is the sheer power of the waves as they smash into the cliff, and they also trap air and water into any holes or cracks in the cliff, which causes the rock to break apart. So that's hydraulic action. Okay, abrasion is again a type of erosion where the material that's actually in the waves, once it's broken off the cliff, gets thrown at the cliff itself, and it acts like sandpaper and it wears it down, again causing it to erode. So that's often called the sandpapering effect, but the proper term is abrasion. Attrition is where rocks that you've sheared off the cliff by hydraulic action hit into each other within the waves, and again bits of them break off and they become smoother, smaller, more rounded. And then finally, certain rocks you find at the coast, things like limestone, so chalk is a good example, can dissolve very, very slowly in just seawater, because seawater is ever so slightly acidic. So all of these different types of erosion have got one thing in common, really. They are breaking down and removing material from the cliffs or from the beach or from wherever it might be. Okay, so these are all types of erosion, and that's what makes erosion. It breaks down and removes material. So what I'd like you to do is pause the screen, get the resources that I've got for you on 365, and just do a little sketch which basically in picture form, very, very basically, in picture form describes or shows what hydraulic action is, abrasion, attrition, and solution. Okay, so once you've done that, please unpause the screen and then you can carry on. Okay, now coastal erosion happens pretty much all around the coast, anywhere you have a coastline, but it doesn't always happen dramatically or fast, and in fact some places it's happening so slowly that you might not notice it at all for thousands if not millions of years, which unsurprisingly humans aren't knocking around for. So we need to be aware of the different factors that can affect the rate of coastal erosion, and it's important to recognize that all these different factors can be happening at the same time, or some of them might be happening at one point or another, whereas others might not happen at all. So these are all the different things that can affect how fast erosion happens at the coast. Okay, so now you know the four types of erosion and the mechanisms that the waves have to break down the cliffs. We now need to look at why cliffs erode at different rates. So one of the reasons is that if the waves aren't very strong, they're not going to be able to do much in the way of erosion. So if you have a gently, not very windy day, a nice calm day at the beach, the waves are not chucking sediment at the cliffs all the time. Otherwise, if you went to the beach and put your feet in the gently lapping waves, they'd be pelted with pebbles, which they're not. So if the wind is strong and can create big waves, it will create greater rates of erosion, potentially. Another factor is how wide the beach is, or if it even has a beach. So beaches are really, really handy ways to protect cliffs. So when you think about the coastline, the beach is a bit of a transition stage between the sea and the land. And if that beach is really wide, it means that when the waves are travelling up the beach to get to the cliffs, they are having a lot of their energy absorbed. If you imagine trying to run and sprint as fast as you can on a beach, and then you compare that same kind of sprint to on a track, the track is going to give you a faster time because it's not absorbing your energy into itself, it's springing it back, whereas the beach is very yielding. So when you put pressure on the sand, you sink in a little bit, and that reduces some of the energy that you can use to drive yourself forwards. Waves are no exception. As waves go up the beach, because the sand can absorb that wave energy, if it's a really wide beach, by the time the waves get to the cliffs, they've run out of energy, so they can't erode it. If you've got a very narrow beach, the opposite is true. So if the beach is not really very wide, or there's not one there at all, there's nothing stopping the waves from just bashing the cliff massively, particularly if they're big waves. Another factor, if your geology is hard or soft, and we've already looked at this already, if you've got a resistant geology, it's far less likely to erode fast. And the erosion rates of things like granite, for example, are incredibly slow. You're talking about millimeters every 10 years. Whereas if you've got a less resistant sedimentary rock, it can be 10 meters a year. And there are some parts of the UK where the erosion rates are up to 10 meters a year, which seems incredible, but it's true. The type of wave, and again we'll get onto this a bit more in the third lesson of coasts, whether the wave is what we'd call constructive or destructive. For now, I would just write down those notes. We're going to add a bit more to that later on in one of the other sessions. The fetch is the distance of open water that the wind blows over. Now, what that means is if you've got a very big, wide expanse of ocean before you get to land, the chances are the wave energy is higher, and therefore it can erode more. And you get bigger waves in islands that are surrounded by massive expanse of water. So if you think of Hawaii is in the middle of the Pacific Ocean, and it's where most of the best surfing tournaments in the world are held, because you get the best waves. By best waves we mean biggest waves, and they're big because all around the island is just this massive expanse of thousands of miles of water. And then finally, does a place have coastal defences or not? So, if you've got coastal defences, if they're doing their job properly, hopefully it should reduce the coastal erosion rates. It doesn't stop them altogether, but it can reduce them. Some parts of this country have loads of coastal defences, and again, you'll find loads in East Anglia. Some parts of the country don't have any defences, but it doesn't mean they're eroding lots, because a lot of the time they don't have them because they don't need them. Aberdeen, in the north east of Scotland, is called Granite City for a reason. It's predominantly granite geology, and it's very, very resistant. So they don't really need groins and seawall and rock armour to protect their cliffs, because their cliffs are so hard they protect themselves. Whereas the soft sort of sands and clays of East Anglia need a lot of protection, and even with protection, erode far faster than the cliffs of Aberdeen. So all of these different factors you need to jot down, because they can affect how fast or slow coastal erosion can occur. Okay, when you're ready, unpause the screen. So I'm going to skip through this, but briefly kind of mention it to you. The reason I'm going to skip through this is because it's solely for the purpose of practicing 8-mark questions. Okay, but the caveat, and this is what I want you to be fully aware of, you will not get an assess question of this, which this is practice of, in this topic. It will not appear. The only 8-mark question command word that you get for this topic, for UK's changing landscapes, is examine. The reason I've put an assess question in there is just so you can practice how to structure assess questions in general. Alright, so this is just a reminder, because I don't want you to forget that assess questions exist for all the other topics. If you can structure it, you should be able to structure it for any topic. Even though, again, I'll say this really clearly again, you will not get an assess or an evaluate question in the UK's changing landscapes topic. The 8 markers, there's 2 of them, will be examine. That will be the only 8-mark command word. Okay, so, but just if you want to practice assess questions, which I would always recommend anyway, to get used to doing the structure whilst you're doing a topic which doesn't have them, I'm just going to outline it here. Okay, so you can pause the screen. Okay, there's the question you can practice doing. You can pause the screen and then do this, so you've got an idea again how to structure these assess questions. This is additional extension work for those of you that really are keen to get the exam technique perfected as well as possible. All right, so you pause the screen and write that down if you want to, and if you don't want to, you can completely ignore it, and then we're just going to move on. All right. So then again, there's my little caveat in big yellow letters. You will not have an assessed question in this topic in the exam. Only examine will appear, but this is for if you want to practice. Okay, right. And then if you have done that, here's the mark scheme that you can use to see what level you'd be. Level 3 would be sort of 7 or 8 marks. Level 2 would be 4 to 6 marks, and level 1 would be 1 to 3 marks. Okay, so pause the screen and self-mark, and if you really want extra feedback, send it to me and I'll happily mark it for you and give you some feedback. Okay, so now we've had a look at erosion processes, which you can see all here at the bottom. Okay, you've got waves coming into the base of the cliff, you've got hydraulic action, or hydraulic pressure they call it here, abrasion, which is the rocks hitting the cliff, attrition, which is the rocks hitting into each other, and solution, which is just the dissolving of certain rocks. You can see that these waves and these erosion processes, okay, in black lettering, affect only a very small part of the cliff, the base of the cliff. And the reason they affect the base of the cliff is because that's where they are happening. The waves can have no effect on the top of the cliff because the waves don't reach up to the top of the cliff. So waves, which are the erosional kind of force, so to speak, at the coasts, can only erode the coast where they hit, and they can only hit between the high and low tide or water marks. So erosion is really only happening here, okay, at this point. Weathering is the next thing we're going to be looking at. So weathering, which is in the blue lettering, can occur anywhere on the cliff, and mostly it occurs at the top and at the kind of exposed face of the cliff. And we're going to start to look at weathering now. Okay, it does say click on the image for a video. This video is on 365. So again, please just watch the videos in the section on 365, and you can get again a bit of a summary about erosion from the video. So weathering, this is just a simple case of writing down the notes, okay? Weathering and erosion are often confused because they're very, very similar. The reason they're similar is because they both break down the rock. Erosion breaks down the rock by hydraulic action, abrasion, attrition, and solution. Weathering breaks down the rock through mechanical or physical processes, chemical processes, or biological processes. But the difference, the clear difference between weathering and erosion is that weathering doesn't remove the rock. Erosion can. So erosion can only happen when there's something there that can take the rock away once it's broken it down. In this case, the waves. So the waves themselves break down and remove material, so it's erosion. Weathering is just the breaking down of material. So that weathering can affect above, and I'll go back to this one, weathering can affect where the waves can't reach. So it can still break down the rock. And then if you add gravity into the mix, we get something else entirely called mass movement. But weathering breaks down the rock, doesn't remove it. So the three types of weathering, you've got mechanical weathering, sometimes called physical weathering, and the example I'm going to give you is freeze-thaw. We've already encountered freeze-thaw weathering earlier on in this topic when you looked at natural factors that affect upland landscapes. Okay, but this is now happening at the coast, so this is just extra notes I'd like you to jot down, please. There is a video that explains what freeze-thaw weathering is and what it involves. If you want to and you feel you need to, please do watch that. Chemical weathering is where chemical reactions can break down rock. Again, a bit like solution when it comes to erosion measures. So rainwater, like the seawater, is slightly acidic and it will dissolve things like chalk, limestone, etc. And then biological weathering is any breakdown of rock by animals or plants. So the roots of plants can get into cracks and widen them. Animals like birds and rabbits can create burrows and nest in the face of cliffs, and again breaks down the rocks and breaks down the cliff material. So what you need to do, please, is pause the screen to make sure you've got all three notes for all of these three types of weathering. So when you're ready, unpause the screen and I'll carry on. Okay, so the last thing that I wanted to look at this session, which I know you've been kind of writing lots and lots of notes, but we really need to get these processes done and dusted, is this idea of mass movement. Now, mass movement is pretty self-explanatory actually. It's where large chunks of material fall from the cliffs onto the beach under the force of gravity. Okay, they move en masse, and mass movement requires a combination of erosion and weathering plus gravity. So think of mass movement as an equation: erosion plus weathering plus gravity equals mass movement event. And I'll explain that in a bit more detail in a bit. So if you've got erosion happening at the bottom of a cliff, and you've got weathering weakening the top and the face of a cliff, if there is a slope, gravity can take over, and it can cause major kind of movement of large amounts of cliff material in one go. And that's what we call mass movements. So we're going to look at 3 mass movements that affect the coast, and there is a handout on 365 with all of the notes you need. I will talk you through them all, and all you need to do is match and color code the picture to the title to the explanation of what's going on. All right, so again, all the notes are there for you. If you want to write the notes out, feel free. I'm going to go through them anyway, but it's all there if you need to get it on there. So the first type of mass movement is rockfalls, and really we're interested in this pile of rocks over here. This has happened, and these have fallen very dramatically in a very quick kind of event. And the reason I know that they've come from the cliff and not from the sea is because they are angular. Okay, they've not actually been broken down through attrition by the waves, otherwise they'd look like pebbles. So this very tall cliff and very steep cliff has undergone a mass movement event. Okay, so why has that happened? Well, this is the diagram that you need to be looking at on your handout, which shows that. And again, angular material falling from the cliff face down is very straightforward. The fact that, once this material's been broken down, it falls. But what has created the fall? Why is there a drop in the first place? So that's why we need to talk about erosion and weathering. So at the base of the cliff, hydraulic action and abrasion, HIDE and AB, you would obviously write it out in full in your exam, erode the base of the cliffs, and what that does is it undercuts them. And what that means is it creates this steep cliff profile. So now you've created basically a platform for gravity to work its magic. So waves erode at the base of a cliff to make it steep, and then biological weathering or physical weathering, so freeze-thaw physical weathering, can shatter and break down material in the face of the cliff, at the top of the cliff. But because it's unsupported, because essentially the cliff's been eroded at the bottom, there's nowhere for it to go but follow the physical force of gravity. So the big chunks of rock will break off and then gather at the bottom of the slope. And at the bottom of the slope, we call that a scree slope. So the characteristics are that it's very angular. It's in a pile of scree at the bottom. It's just often very close to the base of the cliff. And it involves erosion, weathering, and gravity. Okay, so slumping is the next one, and this one we should be, if you've ever been to the coast around East Anglia, you'll be far more familiar with this. This is something which happens where you've got soft geologies. So this will only happen, okay, where you can only create steep cliffs if this rock is hard and resistant, because it can support its own weight. Okay, think about a Jenga tower. Okay, hard wooden blocks, they'll support their own weight. But if you try and make a tower out of jelly, it doesn't work. You can't make a nice long tower out of jelly, or well, maybe you can actually, jelly. Custard, okay, let's take custard instead. Custard just sort of can't support its own weight because it's not solid enough. And so it'll slump and it'll slide and it'll create a gentle cliff profile. And that's what slumping is really. It's where chunks of land, like you can see here, kind of slump down. If you slump down in your chair, you kind of sag a little bit. And there's a few things going on to create slumping. So this again is where you can complete and match your diagram. Here you go, here's a cliff, and you can see this is not a steep cliff, this is a gently sloping cliff which is formed of soft geology like sandstones and clays and things like that. So that's what we've got here. We've got some sandstone and maybe a layer of clay underneath. And you've also got waves still attacking the base, okay, because that's important too. But first and foremost, soft geology. That's what you need to begin with. Then you need to make that soft geology quite heavy, and the best way to make soft geology heavy is to soak it in water. And out of the sky is plenty of that. It's rain, so rain will saturate the top of these cliffs through this sandstone, which will just sink into it, make it really heavy, and it will gather. When it gets to clay, it will gather because clay is waterproof. It's impermeable. So the cliff and the rock gets really heavy and then is sitting on this slippery clay surface. Then, if you add into it waves undercutting at the base, hydraulic action, abrasion, then you're taking away the feet of the cliff, which is the only thing stopping it from collapsing at the now. So you make it really heavy, you give it a slippery slide to go down, and then you take away its feet. What's going to happen? It's going to slump. Okay? And so you've got from this to this as a result of all those things happening at once. Soft geology, heavy material, rain, a layer of clay, like impermeable rock, and waves attacking the base, taking away the base of the cliff, taking away the support the cliff has, and that's going to lead to this slumping motion. Okay, so again, use that information to make full notes, match up your diagrams. Okay, and the very last type of mass movement we're going to talk about is sliding. Now, luckily, this is quite a rare occurrence. It doesn't happen as often as you might think, and that's fortunate, because if sliding does happen and you happen to be at the coast at the time, then there's not much hope for you. So this is very similar to slumping, but you can have hard geology. That geology just needs to be tilted slightly towards the sea, or have like an angled, what we call bedding plane. Now this is layers of rock, so these rocks must be sedimentary because they're formed in layers here, you can see, and it might have little joints, okay, that allow water to go through. So if, imagine rain is coming from up here, okay, it soaks through these little gaps and it settles in these bedding planes, these little areas of weakness, and it creates a lubricating layer. Because this material is now sitting on a flat layer, a slippery layer of water, and it's maybe weakened by some other event, okay, maybe building on top or whatever it might be, then it has the ability, it doesn't often happen, but it has the ability to slide towards the sea, and massive chunks of rock can slide all at once. We don't really see this happening very often. We see this happening far more often on land, like inland, not at the coast, but it can happen, and it does happen, so just so you're aware of it. So sliding would literally be that rapid movement downhill of large kind of chunks of rock. So it's like slumping, but on harder geologies where they're tilted towards the sea and they're lubricated by the rain. Okay, so again, rockfalls, slumping, sliding, you should now have all the notes on those different mass movement types. Alright, so just to finish off, just to test your knowledge, okay, here is an exam question. This is not one that has appeared in the current exam board series, but it's one that I've got nonetheless. Study figure 1a, it shows Compton Bay in the Isle of Wight. Which process of mass movement has occurred at S? So S is here. What type of mass movement, the things you've just done, has occurred here? It's either rockfalls, slumping, or sliding. What do you think? What are the clues? I'll give you 30 seconds just to think about that, and then I'll give you some answers. So if you don't want me to reveal it, pause the screen. Okay, the answer is slumping or rotational slumping. They even allowed landslide, which they shouldn't, okay? But the reason we know it's slumping, this material is clearly very soft. The cliffs themselves are gently sloping, which tells us they're soft material, okay? They're not a steep cliff. You can also see that there's grass here, which suggests that the grass used to be up here, and there is a sort of a rotational kind of shape to the back there. So this is clearly a rotational slump that's happened. Okay, what about this photo? What type of mass movement has occurred here? And again, why do we know that? Okay, so you should have identified that this was a rockfall, and you can see that because a few things. Firstly, you've got a pile of scree that's at the base of a cliff. You can see it's hard geology because it's a more vertical cliff face. And also the rocks you can see are angular. Okay, they're not rounded like pebbles, they are angular rocks. So they've not been put there by the sea. So large amounts of material in a scree slope, vertical, hard geology cliff face, and they're angular rocks. All right, now I'm not going to make you do this for homework. This is just something you could do just to help you. But when you think about mass movement events, try and think about them as ingredients. Okay, this is again is another example of a really good example of slumping. Again, gentle cliff slope, soft geology. Clearly, you've got this bit of cliff face that's slumped down because it's probably hit a layer of clay, which has caused it to slump down that way. I don't want you to necessarily say do this. The homework was complete the mass movement cut and sort. You should have been doing that through the session as I was talking. So hopefully you haven't actually had to do that. This has been a very long session when it comes to the first kind of bit of coasts. But I promise you, once we get through all these processes, it will all become clear about why you're learning erosion, weathering, mass movement, and the ones to come in the next two sessions. Okay, so make sure you've done your color coding, cut and sort, whatever you want, however you want to do it for Rockfalls, slumping, sliding, and then your notes for this session will be complete. I will see you next time for lesson 5. Thank you very much for listening.